Okay, the talk is about the introduction to Aerospike. How many people use Aerospike? Okay, how many people have heard about Aerospike? Okay, I've heard about Aerospike. That's good. That's not too bad. Okay, so my name is Clarence. So who's Clarence? I'm a principal consultant and developer advocate at Aerospike. I have about 18 years of experience and 8 years in. Let me just close this. Okay, 8 years in designing, developing, training, and implementing NoSQL applications. I live in Mangalore, which is the if people know, it's the west coastal region of India. I live there with my wife, 3 dogs, 1 cat, and a couple of fish. Okay, and I'm a hardcore dog lover. I just wanted to mention that I'm proud of it. Okay. All right. So, what is Aerospike? Okay. So, Aerospike is a real-time, low latency, high throughput, scalable, immediately consistent, multi-modal data platform. Okay. So, what does that mean? So, if you look at the diagram here, you have multiple data models here, right? Aerospike can be used as a key value store. It can be used as a document store. You store data as JSON. You have SQL capabilities to query that data. Use graph on top of Aerospike, okay, which is an upcoming feature actually, which is really very interesting here. I want to talk about that a little bit. If you have seen many graph features that are out in the market, what happens is there's a lot of ETL that happens in graph, right? The graph itself might be fast, but the data to be loaded to graph takes a lot of time. I previously worked with a graph-based database company. So I was working with a customer with about 3 terabytes of data, which is not very huge nowadays. And from ADL, that is from Azure Data Lake, to transfer that data to this graph engine, it took about 2 days. Right. So once the data was in the graph, it was fast. That's okay. But what about the ETL? The ETL itself is going to take a lot of time, right? Which probably is not acceptable. 2 days on from ADL to the graph system is huge, right? So that's where Aerospike comes into picture. Your data is stored in the database and you have graph on that, right? So it's going to be seamlessly working. You can use that as time series engine as well. And other than that, you have real-time engine, dynamic distribution of data. You have query and search services, change data notification, smart cluster management. So if a node goes down, you don't have to do anything about that. It's dynamically managed, right? Something that you as a DevOps guy would love, right? Instead of you having an administrator there who's going to keep looking at the system, whether it's working or not working, and somebody has to handle it, right? So other than that, what we offer here is the core of Aerospike. That is, you can use Aerospike as in-memory, okay, or persistent memory, or most of the times, the beauty of Aerospike is when we use it as hybrid. Okay, we're going to talk about that. Okay, hybrid memory, which means your primary indexes are going to be in the RAM, which is going to be a little bit of RAM. Your data, majority of the data will be stored in the disk. So what we take advantage of is the way how the data is stored in your SSDs. Take advantage of the SSD architecture. Instead of you storing the data as files in the operating system, you're going to store data as raw blocks on SSD. So that's the advantage here. So that's how that fast lookup can happen. Get my point, right? So that's the biggest advantage there. Okay. All right. So a lot of customers use that, and I'm going to go a little fast, okay, so that my co-speaker also gets a chance to speak on how it can be used in different use case. Okay, so hybrid memory architecture, intelligent dynamic cluster management, strong consistency. So it's only NoSQL database which can be AP as well as CP together. Okay, not all NoSQL databases offer that. You have availability and partition tolerance and strong consistency as well. Right. So Aerospike can achieve that. So that's one of the examples actually. That was from one of the customers' screenshot. Actually, very interesting. I just wanted to put this. Generally, I don't put this in a meetup, but still, I was so tempted. I put this. Look at this. The latency that we replaced Cassandra with 4 to 9 milliseconds that was taking was replaced for less than 250 milliseconds. Right. So you can see there is a drop of a huge drop. And the data volume that was handled here was 450 terabytes, while what Aerospike was handling was over 1.3 petabytes. Okay, and likewise the servers. Okay, there were more than 200 plus servers. Okay, and with Aerospike we replaced them with only 28 nodes. Right. So what I'm trying to say is the TCO. Right, the total cost of ownership is 10x less here. Right. So that's the biggest advantage. Another financial services fraud detection use case. Can I tell them? Can I name the customer that it was PayPal? Okay. All right. Okay. The latency you can see here. They used RDBMS and a cache in front of it. Generally how people used to work for a long time. Okay. The latency was 1 to 2 milliseconds. That was brought to less than 200 milliseconds. Okay. And likewise, the volume, 10 terabytes of data to 100 plus terabytes of data that could Aerospike could handle. Throughput from 200,000 TPS transactions per second to over 1 million transactions per second. Correct. And the servers, you can see more than 360 nodes Oracle rack was replaced by just 28 Aerospike nodes. So you can see there's a drastic difference here. Right. So
the 360 are nodes for 10 terabytes?
Yes, that's correct.
Isn't that a bit excessive?
Yeah, that is actually, but that's how it was. Because on the top of that, they used Redis. That was also not working. On the top of that, they had Redis as a caching layer. Okay. So why developers love Aerospike? Mostly because of scalability, performance, multimodal API that you can use document, key value, as well as graphs. You have persistence data, which means you don't need caching in front of it. Okay, that's another advantage. Most of the databases use database and then you have a caching layer, right? So that's something that's completely eliminated now. And language agnostic. You have multiple APIs. You can write in one language and read in another language. So it's completely okay. Okay. How about DevOps? You have resiliency, inter database replication, automatic sharding. You don't get up in the middle of the night and see if the node has gone down or something. That is for seamless scale and up down. Automatic sharding is the data is automatically sharded to different nodes. Okay, which most of the database does. Okay, it's something very special. So the biggest thing is the total cost of ownership here. Okay, that becomes more than 10x less, especially when the data grows. Okay, because most of the time, right, the story goes something like this. A couple of years back, when we talk about big data, right, people with 40 GB of data used to call them as big data. Right, 40 GB, and latency like 1 or 2 milliseconds, they used to call it as fast, right? But that's not true anymore, right? We have grown like 5 or 6 petabytes of data is very common, especially in bank kind of use cases. 5 or 6 petabytes of data is very, very common to see today, right? And you're looking for sub-millisecond response time. Okay. All right. So how do you get started with Aerospike if you're new? Okay. You just go to developer.aerospike.com or use one of our hundreds of Jupyter notebooks, very well written. Okay, just copy that and download it and just execute it. Okay, or if you really want to try hands-on, go to the docs, see how it is installed and so on. Or we have something called as Aerolab, so you can use Docker to create multiple nodes and use that. That's also fine. Let's take a quick example because it's like more of the agenda is about like how to work with Aerospike, right? So I want to show you a simple example, extremely simple example, to show you how easy it is to work to get started with Aerospike. You just have to create an Aerospike client. Okay, is equal to new Aerospike. Pass null. I'll come to that. What null is? You just have to pass the IP address of where Aerospike is installed and the port number 3000, and that's it. Okay. So what basically happens here is the Aerospike client connects to the Aerospike server. Okay, and that client. Okay, so whatever IP address you pass there, so maybe this client basically tells who are the other. This server basically tells who are the other servers. Okay, with that, and ultimately it returns. connects to the entire cluster. Okay, it returns something called as the partition map. Okay, we'll talk about that later. Okay, so this is fine, but what is the issue here? The issue is, what if node was down, right? Because you're connecting to one node. So if you don't want that, you connect to multiple nodes, right? Generally, the best practice is, if you like have a 32 node cluster, you pass one node in each rack. Okay, if you have 32 node cluster, you probably have 4 racks, right? You, as a best practice, pass one node in each rack. So that's extremely simple. Okay, so what about that null? So you can see the first parameter, right? So why am I talking about that is, all commands, right, are in the same format. The entire API is in the same format. It generally takes 3 parameters. The first one is the policy. Okay, so the important thing here, what I missed, which I passed, was null. When I pass null, is the default policy. So what policy basically says here is the everything about how the operation is supposed to happen. Like, for example, okay, this is the code that is to connect, right? So how am I going to connect? What's the username? What's the password? Should it connect via LDAP? What are the security settings? Everything else is defined in the policy. So you need to create a policy object and define all the settings that you want to, and pass accordingly. Make sense? Okay, so it's that easy. So let's take an example of how Aerospike data model looks like. Okay, so if you want to do a one-to-one comparison with relational database, so what you call it as schema in relational database is what we call it as namespace in Aerospike. Okay, so what happens to a row? Okay, what happens to a row? So row becomes a record in Aerospike. So every row is what is called as a record, and every column is what is called as a bin. So for example, name is a bin, email is a bin, the bin, right? This entire is a record. So one column is basically a record. Make sense? Okay, so generally it's a key value pair. You can see it's a key. The record has a key and value. Okay, and value is made up of multiple bits. Okay, so that's an example how you can insert data in Aerospike. You just create a client, the one that we saw. You're creating a key. Okay, when you create a key, it takes 3 parameters: the namespace, the set is basically the table. Okay, the namespace test, set customer, and 1 is the key. Okay, and look at this, what I'm inserting client.put null. So what is this null? The first parameter, policy. Okay, so what am I doing? Put is a read operation. So what kind of policy is this? It's a write policy. If it was get operation, the first parameter would be a read policy, right? So all API is very consistent in that sense. Okay, so policy could be anything. Like, okay, when you're writing, for example, okay, what kind of durability setting you want to give, what kind of acknowledgement settings you want to give, everything goes in the policy. You create a write policy object and give all the settings there. Okay, so you have key, the policy, the key, and now I'm creating 3 attributes, 3 columns, right? The name column is Joe, age column is 28, and addresses column is a list of addresses. You can see here, it's a map of addresses, right? So this is what is called as a CDT, or container data type. While these were scalar values, this bin is a container data type. So first column is Joe, second column is or second bin is age, the third bin is a CDT, container data type. It's a map in this case, right? So at Aerospike, you can store data as scalar values or lists or maps. You have multiple data structures that are supported. Okay, so that's an example. So this example is where you can use the document database. So instead of Aerospike client, I'm creating an Aerospike document client. Oops, sorry, that was a touch screen or something. Okay, I don't know. Okay, so what's going on here is you can see I've created an Aerospike document client, and how I can read is by giving the JSON path. So I can use the standard JSON path to read anything in the document. If this was the document that I was storing, okay, so I can give the standard path here. So here you can see from the root, I'm telling everything in the zip. okay, which equals to this. Okay, so I can do that. Or here I'm from the root, I'm telling, okay, get me all the streets here. So you can see street here, street. So it gives me array of 2 streets. Okay, so the standard JSON path. Okay, so how is it fast? So we discussed all this, right? So how is it fast? So what happens is Aerospike has a constant partition map. When the client connects to the server, it retrieves or get back something called as a partition map, and it has exactly 4096 partitions. Okay, in the partition map. Okay, so let me just show you here. So you can see here what happens. You have 4096 partitions. You have the master copy and the replica copy. So the every node has the same partition map, as well as the client also has the same partition map. So when the client has to write data to the node based on the partition map, it knows exactly to which node it has to write. It doesn't always write to the master node or something. It knows which node it has to write. It is node 3 or node 4, depending on partition map. And how this is happening is by hashing. Okay, and we use called an algorithm called ripe MD360. Okay, I hadn't heard about this algorithm before I joined Aerospike. You don't have to worry about that anyway. Okay, so what happens is if you are trying to write this, test customer and say the document with key 1. So what's happening is it's going to hash. Okay, so once it hashes the first 20, it's going to do a 20 byte hash, which is called as the digest. Okay, the first 12 bits of it is what is called as the partition ID. So it picks the partition ID from those 12 bits and identifies to which node it has to write the data. Okay, so it doesn't write always to the first node, and the first node doesn't decide on which node the data has to go. The client knows which node the data has to be written. Right, so it's an active kind of cluster than a master slave kind of scenario. Okay, all right. Aerospike has 2 layers. You have the index layer, the storage and storage layer. Okay, so the storage layer can be however you want. Okay, it could be all in the memory. It could be backed by in the memory, backed by SSDs, which is the hybrid model, which is the most used model that we use. Okay, here in this case, you want to keep all the data in the memory. Okay, imagine you have say a couple of terabytes of data, so you might not be able to afford a couple of terabytes of RAM, right? Okay, so it's very nice, very interesting for small use cases. Okay, but most of the use cases is when we want your index to be in the memory and your data to be in the disk, petabyte kind of use cases. Okay, some use cases use complete on disk index as well as data in the memory. Data in the disk, everything in the disk, which is called as the all flash scenario. We also have in PMEM also, but because Intel stopped the PMEM kind of thing, we reduce that usage. Okay, so what is very important here, okay, to understand here is the data is stored in the raw SSD here. See, I'm not storing it in the file system. Okay, if you see most of the databases, they store it as file. So which means you have the operating system layer, which is trying to read that file. No, I'm not going to do that. It's going to take advantage of the SSD, the underlying storage architecture. Okay, so how is it doing here? So a typical read operation you can see here, the client sends the digest from there. Here, internally we have something, the primary index is divided into something called as sprigs. Okay, sprigs is internally a red black tree. Okay, it's a RB tree. Okay, where it's stored on every node. Okay, sprigs are there, and these sprigs actually point to directly to the SSD where the data needs to be read from. Okay, likewise the write also exactly the same process. Okay, it buffers there's buffering that happens, and then the data goes via sprig directly to the SSD, and from there from the sprig it can go to a different node also, depends on how many replicas you have. Okay, again the focus is the data is directly written to the SSD. Okay, so likewise when you're installing and configuring Aerospike, when you're provisioning the disk, you provision an empty disk without operating system or a partition. Okay, that you point out where the data has to be read or written from. Okay, we have other tool support also, like we have Aerospike Quick Look. Okay, it's a very small testing kind of interface that gives you SQL kind of commands to access data that's stored in Aerospike. It's not really as powerful as SQL, not even comparable to that, but it's just quick look as it says. Okay, not for some real huge data kind of querying or something. Okay. Uh, Likewise, you have ASADM also, which is a tool for managing the cluster. Okay, we cannot go to the details of that, obviously because of the lack of time. And other features that we have is we have collection data types. Like I told, we have powerful expressions. You can use expressions to query your data in Aerospike. Batch operations. Of course, you have to use batch operations, isn't it? When you're writing, especially to the SSD, multiple reads or multiple writes. Okay. We do have querying, and concurrency control also. Okay, and of course we have a set of connectors that are supported for be it Kafka, be it Elasticsearch, be it JMS, anywhere. Okay, and that's what you can get more resources. And I'll hand over to my colleague. Okay. Just because
Thank you, Clarence. Yes, I think Clarence just now introduced the Aerospike basic, and also how do we make use of Aerospike and what is the advantage to use Aerospike. And next, I'm going to introduce some real business scenario of use cases, how we make use of it to deliver our targeted ads in Rakuten. So I myself is my name is Rongxin, and I work with some of the members here to develop different kinds of advertisement systems in Rakuten. As we may know that Rakuten itself is an e-commerce company in Japan, one of the biggest e-commerce company in Japan, and advertisement business is one of the big revenue-bringing services in Rakuten. And a lot of us are part of this ads team. What we are building is different kind of ads to support e-commerce, to support our merchants, support also the users, the buyers, to get the correct items they are interested in. And so today I'm going to talk more about some subset of the ads we are supporting, and this kind of ads we are using Aerospike as the core database for delivering the recommendation and also store the user mapping in order to achieve the business goals. So I'm going to talk about what is the targeted ads in the e-commerce perspective, and also introduce some high-level architecture for ads delivery in our case, and how do we make use of Aerospike as a core database engine to deliver our ads, and what are the recent activities, recent updates we have related to Aerospike. Yeah, Rakuten as an e-commerce company has many types of ads. We usually categorize in multiple areas. It can be non-targeting, it can be targeted. For non-targeting ads, we can see is very classic ads, for example, banner ads. As we show a picture of a brand, we call it a branding ads to promote some of the brands. Those kind of ads are very classic. They don't have any targeting. So it applies to all the users who visit this page. But nowadays, for the e-commerce platforms, whenever we visit some of the pages, we want to direct user who are interested in some of the products that they are interested in or they may be interested in. So how do we increase the sales for the merchants? This comes with the targeting ads. The targeted ads can be of a group-based targeting. That means we are targeting a kind of group of users, like a genre, a category of users. And it can be a very specific targeting that we target to a specific user. For example, targeting myself. I myself can be a list of products that the Rakuten thinks I'm interested in. And this Aerospike is kind of a database that's perfect for user-specific targeting. And the reason is, for ads business, the users always are unpredicted. So whenever we have the users from the internet, it can grow drastically. And for each user, if we want to do the targeting, that means for each machine learning model for recommendation, it can double, triple, or many times of the data we have. And a single database will not be able to accommodate it, and also with the fast speed. So as this diagram shows that we have two major kind of roles, like merchants, they want to promote their items, and users, they want to buy something. So merchants make use of the ad management to do the self-service, to configure the ad campaigns, what kind of a performance ads they want to serve, they want to buy. And those targeted ads, once they are serving, they will be running and with the tag recommendation logic to the actual users who visited either the website of the e-commerce itself, the marketplace, or even outside Rakuten, because we have something called ad exchange, or we show the ads outside Rakuten. For example, in Google or some other websites in Japan, you can see ads that is for this cake is really good for you. Once you click inside, it will be redirected to Rakuten's marketplace. So that's the targeting. So for targeting, there are two kinds of things. One is tracking. We need to know who are you. Another one is recommendation. We need to generate a lot of different recommendations based on your behavior or based on your past purchase behavior, or based on your demographics that we think you may be interested in something. So all this kind of data will be hosted, targeted into the Aerospike for delivery. Yeah, user targeted ads in Rakuten may introduce two kinds of ads that we are currently supporting, especially in Singapore side. One of them is called behavior targeting ads. That is based on your behavior. As common frequent users in e-commerce marketplace in Rakuten, we know by gathering the tracking related things that we know that's what you may be interested in. So for BTA ads, we have list of recommendation logics to run every day or even every hour by machine learning departments to generate a list of items that you may be interested in every day. And another more advanced type of ads is called performance assured ads. Also, sometimes we call it CPA because merchants or advertisers only pay the ads whenever advertisement is converted to action. In our case, in e-commerce case, the action means a purchase. That means when a user sees ads, he is interested in that because he thinks it is relevant. He clicks in and saw the item, add to carts, make payments. That is one conversion. That merchants pay for that. So this is called performance structured ads. And the cost model is called cost per action. And the behavior targeting ads is pretty common in the ad industry, that we use CPC as a model. CPC is the cost per click. It means whenever you are interested in the ads, you click on that, the merchants, the advertiser will be charged. So these two types of targeted ads can cover a lot of scenarios in the e-commerce sites, especially focusing some ad spots that are long tail, because for tendency ads or some static banner ads, they can be in the homepage. But if you go into deep into several layers of the e-commerce websites, we want to have the ads that's really built for a specific user so that you will be interested to clicking. Otherwise, it's a waste of ad spot. Yeah, that's why the targeting ads very useful for the e-commerce, because in every place we may let the user to find something interested. Instead of they always search by themselves. Of course, we provide search types of ads similar to Google. You search item, we will come to you, but search types of ads may not be the user targeting. This is a high-level architecture of how we deliver targeting ads. It has some components, like it starts with the tracking DB. This tracking DB is not a database. It is the big data warehouse or big data platform in Rakuten. So it contains all of the tracking information that Rakuten as an e-commerce site or its system services that we collect based on the user's behavior or different kind of behavior that we share, and by the machine learning engines with recommendation engine and user mapping engines, we aggregate, clean those kind of data, make use of targeted database for the ads targeted delivery. And we have a front web application. Usually they are the API services to deliver the ads. And the ad delivery for the performance ads or targeted ads is very simple, because as long as we know who the users are, then we should be able to target them and display the correct ads. The display correct ads means we return something, return the ad data to the front end. So we let the front end to show what kind of data they want to have. But there are two kinds of the data exchange here. So when the user comes into the website, we know the cookie. Or if they are using mobile phones, we know your mobile ID. For example, the ad ID in the Android or iOS. If you exclude from the tracking of the ad ID, of course, we don't know you. By using this, we use the user mapping database to translate your cookie, your mobile ID into a internal ID, which is universal within Rakuten. With that, we have the recommendation waiting for the users. Yeah, that's the general flow of that. So it contains recommendation data, user mapping data, targeting DB, and ad delivery engine. All those are highly scalable in different parts. Actually, those two kinds of the ads are created in Rakuten, rebuilt in several years before. Before that, we were using some older technologies. But when it comes to the time of the building, we were thinking what kind of a data store we want to use for user-specific targeting ad services. And we have some kind of requirements. Because of the nature of the user-specific targeting, we need to host a lot of data for targets. That means each user, for each logic, it may have one record. And we have millions of users in Rakuten. It is growing every day. And we always have multiple data models. Also, our machine learning departments always introduce new models and think they are more effective, and they want to do the A/B testing. So the data is unpredictable. We cannot just have a limited database sitting there, and that is not scalable. So first, we need to have a big storage that can accommodate all the data generated from the big data platform. Another one is it should be highly scalable. Whenever the traffic grows, whenever the data grows, we should be able to easily scale our database data store by just adding nodes, for example, adding servers, instead of making a lot of efforts and stop the service and do something or upgrades in the vertical layer. And because of the nature of the ads, we must make it low latency. We need to return the ads in very short time. Another reason is our ad API can be integrated into ad technology called real-time bidding. That means whenever a user sends request to supply side platform, for example, we as a Rakuten, we can bid that we think this is good for the user. We must return our ads in very short time. So we need to compete with the speed. So low latency is one of the requirements also, and it must be highly available. Because for ad services, we need it to be able to serve the ads 24/7. Any kind of downtime is lost of revenue, of course. So we cannot tolerate just some maintenance modes or shutting down the DB in order to do some upgrades. These kind of things are not possible for ad systems. In the end, we chose Aerospike. Why Aerospike? I think the Clarence already explained a lot that the benefit of that is exactly suitable for us. It's high performance. It supports high throughput. It supports large volume, and the way we love it is the way that it can support large volume in SSD mode. Because a lot of NoSQL distributed NoSQL supports scaling easily. Also, scaling supports store a lot of data in the cluster, but due to the nature of the S data, it can be so big that we cannot just put those data into the memory. Most of the NoSQL DBs are memory first. That means in order to provide serving data for low latency, we have to put into the memory. That means when the scaling, actually scaling your memory, it's very different if you scale a server with 64 gigabytes of memory or with 1 terabyte of SSD. The cost effectiveness, we can think of this. That's one of the things we think is very suitable for ad technology. And of course, low latency, even with SSD mode, it can provide very fast speed for ad delivery. Operational wise, it's very easy. We only have like 1 or 2 DevOps member. They can just easily spin up a Aerospike cluster. Even for our developers, can easily just create a cluster with some simple commands, and always easy to add nodes and remove nodes. And whenever there's a trouble happens, like nodes down, server reboots, failover automatically happens. We don't need to worry about that in the midnight. That the automatically shutting happens whenever a server goes down or removed from the cluster. It doesn't affect anything. We just need to put it back whenever it's ready. Here is some expanding of the architecture, how we make use of the Aerospike for targeting DB. And now we have more clear mindset of what kind of data will be from the source data of the tracking. For the tracking, they are the shared data within Rakuten. For example, the browsing, purchase, demographics, user mapping, search click. They can be used within the whole company to do a lot of things. And the advertisement optimization platform make use of this kind of data to create machine learning model or machine learning jobs. Usually, they make use of Spark jobs to run against huge data every day, and they generate many gigabytes of data every day, every hour, and put into the HDFs. And if for each logic, they are in different places. And what we do is we make use of Spark jobs again, because those data are so huge, they cannot be just done with a simple standalone batch, Java batch or Spring Boot batch to load the data. That's too slow. So we make use of Spark jobs, integrate with the Aerospike SDK, Java SDK actually we're using for now. And the loading process is very easy, just KB. We get the user recommendation, we translate into the Aerospike target formats, and we insert into Aerospike cluster. Similar things happens for the mapping data, but mapping data is very easy because cookie mapping or mobile mapping is very just one ID to another value. Yes, after we got Aerospike as a backend store with the enough database, enough data, and they are always refreshed with the most recent recommendation every time. Our ad engine can serve to the user with most updated recommendation that the user will see the recommendation every day. Then we will be able to monitor the effectiveness, the performance of those ads, for example, behavior targeting or cost the performance assured ads. Yes, as we can see, we are actually making use of big data platform to do the loading and do the generation of the recommendation data. And the serving part is pretty simple. They just load the data inside, then read it and serve it. In order to load the data into the Aerospike, we have a subcomponent called KBS or KB component. It contains a list of Spark jobs we created. Those Spark jobs are in charge of reading data from HDFS, convert them into the target mapping, target data format, and after that store into that. So by making use of the Spark distributed the features, we can just write those jobs and scale them easily. Depends on the source data. The source data can be very big or can be very small. So we just need to tune for each Spark jobs, how many nodes we want to use, how many CPU cores we want to use. And to schedule them, we have scheduling engines called Azkaban to schedule either hourly or daily or half day, depends on how and when those data are generated for recommendation. Yeah, and recently, if you see this part, we recently introduced another part which is using near real-time recommendation engines to direct right to Aerospike instead of the batch modes that may take 1 day or half day to get some data into Aerospike for recommendation. So we want to deliver our recommendation much faster than before. In terms of data model we are using is, I can say it's very easy. Just now, Clarice mentioned that for Aerospike 6, we actually support multiple different kind of database, different kind of data models like document-based or graph or others. But due to the simple nature of the ads delivery, the data model is really simple. As we can see, we are using KB only. Everything is key and value. For recommendation, we always have the user's unique key as the key, unique ID as a key, and the value is a map of items. Those items are generated by recommendation logics. So we have each logic one set in the Aerospike stored into different sets, and we have different kind of ad types. So we have multiple sets in the Aerospike DB. So it will be picked up by the ads delivery engine whenever a user requests. And we have some places to control the ratio, when to show what, when to show which logic. And also that will be used for A/B testing as well to test the effectiveness of the ads. This is for recommendation. And another one that we use is even more simpler, which is for user mapping. The user mapping is very important for ad technology. It can be used for the ad exchange or other high-level ads platform as well. The usage is just to translate the tracking ID to the actual internal ID. Tracking ID can be the cookie or the mobile ID, because these are public available, and there can be a lot. Because if I am the user, I use multiple laptops, I use multiple websites, I always can generate a list of cookie IDs. But the target is always my user ID in Rakuten. So we will store this kind of data in the Aerospike in Rakuten, so that we will know you. Whenever you have a cookie, then we know, okay, this is Rongshin, that we're going to recommend these items to you. Just to share some of the recent activities we have, for several years before that, we have Aerospike cluster built with a bit older version. It is 3.14. It has been there for quite some time, and for last year started, we wanted to do the version up because it's already EOL, and we successfully upgraded by running in parallel modes. So old one still running, and new one we built on another infrastructure. We use bare metal instead of VM. So previously we used VM. The data is stored in the file system, yes. And now we use the bare metal. We can make use of SSD directly. That will be much more effective, and performance or stability is much better when we move to the Aerospike in the new cluster. Of course, there are new features as well, because in the new Aerospike version, the monitoring is better. Yeah, the support for the Prometheus exports and the Grafana support, everything we got monitoring, and we haven't made use of any advanced features yet. Yeah, but so far is pretty stable. Another activity we have is the near real-time recommendation. This is actually related to the recommendation teams that we have, because in the past, our machine learning departments always generate huge data, like 500 gigabytes or 1 terabyte of data for us to load. It would take 1 hour, 2 hours to load by Spark jobs. But in order to provide some of the recommendation that can be always ready for the user. For example, I have one behavior, then and several hours later, my recommendation is there in the website. So this is called near real-time recommendation. There, instead of traditional targeting, which runs like, for example, half a day interval, a batch to generate the items ranking or something from the source data and load into the Aerospike. Now there's another streaming kind of a process. Everything is really running in a smaller batch containers in Dockers. Those Dockers run in some data models, and they generate smaller recommendation and stream into the Aerospike. So we don't have any changes in the Aerospike and ad library, but the effectiveness is whenever the user browse our website or marketplace, they can see more recently recommended data products for them. Yeah, this is one of the things we have recently. Yes, some introduction of how I can study some of the information from the past. As from start, we have around 200 gigabytes of targeting data, but along the years, we can see actually its growth. It also because of the new types of ad model we are introducing to serve the ads. For example, the machine learning ad model can create one after another that can greatly increase the usage of the Aerospike. And also because it is possible that we introduce new fields under the items for the recommendation. And also because of the natural growth for the Rakuten users that from different parts of the world. Yes, and we are predicting for recommendation that it can grow always across each year. Yes, that's the end of my sharing. Do you have any questions before we go to the? Yeah.
Either Aerospike or Rakuten.
Yeah, please. Hadoop cluster. Our Aerospike cluster we have in production mode. We have around 20 something. It's not that big actually compared to the users in the industry, because One of the reasons is because those two kind of ads is only the subset of Rakuten's ads. There are ads now using Aerospike. That's yes, kind of these days, but it's always we are able to scale it. So actually, we have more servers in the past. We have actually more than double of that, but because we optimize some of the data model, actually it reduced in shrinking to the current size. That one is petabytes. Yes, PB level. It's many PB. And in Rakuten, we have multiple clusters in different regions. For example, Japan East, Japan West, and Japan Center. So we currently in Japan we have multiple Hadoop clusters with different size. Yeah, I cannot record that, but it's like thousands of nodes. That one is the company shared resources. Yeah.
You don't do any cleanup or flush before it.
Yes. This Aerospike has a concept called expiry, TTL. So for if you don't set that, you can configure a cluster-wide, namespace-wide configuration. Currently, we configure, for example, 30 days. If you don't put anything, it will be cleared after 30 days for our usage. I think it can be always there, but for us, we don't want to keep the old data. And for recommendation logics, depends on the configuration. It can be either 3 days or 7 days. If it is not there, it will be automatically cleared.
Yeah, you can give the TTL at the global level or in the right policy.
Yeah. Yes. Whenever you load data, you can specify it.
That's a long story. There is we can achieve actually immediate consistency. By default, Aerospike works in AP mode. Okay, you want to make it a strong consistency mode, you have to create different namespace. Okay, in a different namespace, you can achieve strong consistency mode. You can take it off it. Okay, there's a lot of things there to talk about that. Yeah. Yes. Yes.
What happens in the case where one node goes and partition?
See, there are two things again. If it is an AP mode, if one node goes down,
network partition happen in one node,
then it has to be in a strong consistency part. Okay, then there are a lot of options based on what are the settings that you have given. Say in case of split brain kind of scenario, right? Depending on what settings you have given, that is when it can choose. Default behavior is AP mode. In split brain scenario, it will not work. It has to be in strong consistency mode only. Okay, that is where strong consistency comes into picture.
Yeah, so sometimes when you say it's both AP and CP.
Yeah, it can be both AP and CP. Yeah,
You can choose either one.
exactly. One namespace can't be both.
Yes.
But a cluster can have both.
So do you have database administrators for your Aerospike?
We don't really need database administrators. We just need DevOps member. So we have DevOps member who are integrated into the Edge team. They usually do a lot of things, not only for database. So we don't have dedicated database members. They will just say, okay, today I have an Aerospike task, and please upgrade for me. They will upgrade it by making use of the automated tools like Ansible to do the upgrades. And it's because it's very easy to operate. We usually don't have we don't need people to be dedicated to that. And also, for example, the sharding is automatically. There's nothing to be done. Yeah, once you set up, you just let it running. If everything, for example, there's alerts that the cluster got some issues, they just need to check it.
One more question here. So say for example, I assume that this Aerospike is about. So what is a typical setup? Is it on EC2 instances with
On a cloud, it's typically EC2. You can. It depends. Like different customers do it differently. Like currently, I'm working with a bank. They are completely on GCP, but for their high availability, they have chosen AWS. So that's a failover scenario. Not not failover, rather I would say disaster recovery scenario. So if this they are deployed in different availability zones in GCP itself. But in case of the worst to worst scenario, the disaster, they have another active cluster that's running on AWS.
My question is more on, do you set these as containers that run in?
Up to you. You can do it as a standalone system, bare metal. We have a couple of customers running on bare metal. A couple of them on Docker, I don't know many, but on GCP, on AWS, yes.
This Aerospike, does it need to be installed on top of the software?
Not on top of a cluster, on Linux. You install on Linux.
So you still need a Linux OS?
Yes.
Okay.
You install on Linux, but then point out to your SSD for its storage. Get my point? So the data from Aerospike is stored on a raw block. So when you are provisioning it, say if you're provisioning an EC2, you would choose one partition to have Linux installed, on which you're installing Aerospike, and create another major partition or add another disk, different way or whatever. Say create another NVMe drive and attach to your EC2, which is going to store the data from Aerospike. Is going to store data on that raw block. So basically, in your properties file, in your settings file, you're going to point out to that SSD, to that NVMe or whatever.
Understand. So you pretty much create a storage, SSD storage, mount it in a certain part in your operating system, and Aerospike will point to it.
Which is correct. Yes. Yes. It could be in the way of partitioning or external drives. It could be either of them. Yes. But yeah. Only for installation of Aerospike, not for the external disk. The NVMe is plain. It doesn't have operating system, nothing. Yeah, that is true. That's why you have an external drive, preferably. You have external drive or say NVMe attached to the server or a partition, which is raw. That's the whole idea.
You always prefer to have the tools, not a SAN, we prefer direct attach.
Direct attach, yeah, not SAN. SAN is, I think the SAN is true with most of the NoSQL database. You want to avoid SAN. People do use, but you want to avoid it.
How does the licenses charge?
Licenses is this guy.
The unique data that you want to might have application copy there, but the license is basically based on the amount of data that you're going to store.
So it's a peer data size. The larger the data is, the more expensive it is, no matter how big the cluster is.
Yeah, cluster size doesn't matter. Yeah.
And then transaction per second is not counted.
No.
So you still get, there are customers who do millions of PPS second latency. Again, hundreds of thousands of throughput that they do. So we don't charge on throughput or we don't charge on the transaction status. It is basically based on the unique data size and also the ecosystem that you have built around the database. When we have several connectors.
Yeah, connectors are charged separately. If you have third-party tool, then it's charged separately.
So Aerospike writes on all this. So does Aerospike take care of the data redundancy?
Aerospike takes care of the data redundancy?
Yes, that's the question. Does it?
No, you have to take care of it.
Because you said you write to the raw disk without the file system.
Yes.
So where's the data redundancy? No, the data is written directly using the logical block address. There's no file system. That's what you said.
Yeah, but what do you mean by data redundancy? The replicas?
Yeah, you write to the NVMe. If the NVMe or whatever you call the SSD or whatever, it fails.
Yeah, so that is where you specify the replication factor. Okay, you have RF replication factor, right? You have replication factor 2 or replication factor 3, RF2, RF3.
Okay, the replication, is it on the same server node or on
a different node?
It will be on a different server.
Yes, that's correct. On a different node.
So the minimum node to have, the minimum cluster size to have redundancy will be how many?
3.
3 nodes.
Yeah, they recommend at least 3 nodes. Your smallest cluster will be at least 3 nodes.
Replication is the only option, or do you have to do the encoding and all?
Like what?
For the data redundancy, right?
Yeah.
Replication. Is there any other
No, we have replication within the cluster and replication. We call it as XDR, cross data center replication across the data center as well.
So there's no like image encoding or
No.
some other way software way.
No.
So you use what synchronous?
Yes, it is synchronous. It's not async.
So if you have 20 nodes cluster, how many nodes can die before the whole collapse?
It depends on how much RFs that you're creating, but again, you can have like 4 or 5 replication factor also, but nobody goes more than 3. At least I have not seen more than 3 replication factor as of now. But again, if in a 20 node cluster, if like 5 node goes down, then it's like a bad setup, right? Right. So basically, that's where you plan for other things, like you have cross data center replication, where in your application, instead of writing to your London cluster, say if 3 node goes down, you declare it like as a disaster kind of scenario from the application, and now your application is pointing to say your Singapore cluster instead of your London cluster. So which is a copy of your London cluster, and everything is working here. So you plan something like that depending on your availability zone across radius or something. You don't wait for like in a 20 node cluster, wait for like 10 nodes going down, right? Or you cannot have like RF 10 or something. Technically you can, but nobody has. Say if you have 1 terabyte of data, you're basically having like 10 terabytes there, right? That's not
Replication at long would be.
yeah.
So I think replication of 3
3 is huge. Okay, still the most of the recommendation is 2, basically, which means 1 active and 1 replica. 2 people have sometimes, 3 very rare, but people still have. I've seen a couple of bank which I'm consulting now. They have a RF of 3, which is okay, which is not too bad. But you know the caveats of that. The data size increases, and so on. And another thing is like data modeling. Data modeling also drastically increases your data size. Especially sometimes wrong data modeling, or sometimes people do data modeling where the array size grows, right? And when the array size grows, your fetch is not sub-millisecond anymore. Correct? If you're looking for sub-millisecond response time, you're focusing on the data model, because the larger the record is, it takes more time to transfer across the network. It takes more space in the disk. It takes more space in the memory. If it's there in the memory, it takes more time to serialize. It takes more time to deserialize. Right? So you're not asking for sub-millisecond response time in that case.
You have documents, view, you have time series, and then you have
Yes.
So are they can you be different type of views or whatever content? I think they put the same set of data, or
Which is correct. Okay, data is one. It's the same set of data, and everything's working on the top of that.
so I want exactly the same data. So now looking at the document.
For document, no. Document, you have to store it as JSON, right? That's the whole idea about document.
That's what I'm asking.
Yeah.
So you have a document.
Yes.
Set of data.
Yes.
So I want to see time series. Just providing my document data has timing there. Right? Can we share the same data?
Time series, for that, it's more of a simulation for us. It is the way how you are data modeling as time series. So there are a lot of time series best practices wherein you store your key as your, say, epoch time, and you store an array of the other values. Okay, and then simulate a time series kind of database.
Yeah, but then can it be viewed as a document?
No, it cannot.
So that's something.
Yes, it's a different data model then altogether, right? Depending on what you are using. Like, for example, if I'm using just key and record, then I cannot read it using JSON path because it's not stored as JSON at all, right? No, it depends on what you're using. Not really. The data is stored differently, that's all. Database is still the same. The data is stored differently.
No, I mean, the same
Two sets of data, yeah, maybe. Yeah, because the way how you're storing is different than the way of retrieving. If you're storing as key and record, then you have multiple bins. So how JSON can be simulated is, one bin record. It's called a single bin architecture. Okay, it was an anti-pattern earlier for us. We never used to like that when you have like key and only one bin. So now what we have is this is one set, and the other set is you have the key and the document. Document is your JSON document for people who want to store directly. A lot of application consume or produce JSON, and you directly want to store it as such and retrieve the data in the form, say, by doing some JSON path querying or something.
These support WebSocket.
We do support, but I'm not very aware of that as well.
So what is it? I have this over.
Yeah. Okay. So
Yes, I think that's the end
this is
of
the
our
last
presentation.
part.
Yes,
Is Sharon here?
please scan.
You want to talk about this?
Yeah, this is a very quick one. We have a Lego rocket set.
Oh yeah, I want to.
Yeah, to give away. All you're gonna do is you got one prize. If you just scan the QR code here, do a short little survey, tell us what you like, what you didn't like, and we're gonna do a drawing usually right now. So I'll give you 4 minutes, and we'll do an instant draw.
Okay, there's an instant draw. So make sure you scan.
So just continue with
So the chance of you are very high. So 50%.
You'll give it 4 minutes. As soon as you're done.
You did already. Where did you get this QR code? Because there is.
It was behind you. Can you stop your screen share already? All of you have already scanned, right? I'm just going to do a draw right now.
I'm going to stop the sharing. Yeah.
I'll do a random name picker for you all to see.